Okay, awesome. I just want to get started because I really would like to give you less homework, so I know you're like, whoa. What? Okay. Oh no, that's me. Okay, everybody, we're going to be getting into radicals. So we just did our rationals unit. Now we're going to be dealing with radicals. A lot of people really like the radical unit. They find it much simpler for them than the rational unit. But you've got to know your stuff. So we are going to talk about rational exponents, which we've already seen this year. So rational exponent would be a fractional exponent. So everybody, a rational exponent. So here is the rule. Well, fun fact for you. Rational exponents, which means fractional exponents, can be rewritten as radicals, and radicals can be written as rational exponents. They're equal. Awesome. Okay. Once again, don't talk. Okay, so here's how I remember. Well, everybody understands something though. Not one is better than the other. Just like factored form and standard form, not one is more simplified than the other. They're just different forms. You didn't change anything switching back and forth. It's just sometimes this form's better for certain types of problems, and sometimes this form's better for certain types of problems. We'll learn that as we go. Okay, here's how I remember. So everybody, a lot of people will forget, well, which one's the root and which one's the power? So I'll remind you of this picture here. Roots are on the bottom of a flower, correct? Roots are on the bottom. And then the sun gives it power from the top. So anytime I have people say to me, which one's the root? I'll say, remember the picture of the flower. Roots are on bottom. So this is the cube root. And then of x to the second power, because power's on top. Okay? Everybody have that picture drawn for yourself. Awesome. It's a cute little trick. Hey, number one, it says rewrite this as a as a radical. What's the root? Cube root. Roots are on bottom of m to the what power? Second power. So we just rewrote it in radical form. Now understand, you could see it written like this. The cube root of m to the second power. Still the same thing. Still a cube root, still m to the second power. So it means the same thing. It just depends on the book or whatever. You could see it written either way. Okay, now this is not on your paper. I just want you to watch. If I have a negative exponent, there's no such thing as a negative radical. So the first thing you would do is fix your negative exponent. Can anyone tell me the rule? Yeah, flip it. Bring it down. You're right. Both of you are right. Flip it over a fraction. Flip the base. So this would be equal to 1 over m to the 2/3, right? Then rewriting it as a radical, that would be 1 over the cube root of m squared. So negative exponents won't scare us, right? Next one, number 2. What's the root? So square root, roots are on bottom of m to the what power? 5th. Is everybody good? Yeah, good point. So notice I didn't write anything in here because we know it goes without being said, if nothing's there, it's a square root. There's no such thing as a 1th root, okay? All right, so look, how would I rewrite this one? This is equivalent to 1 over m to the 5/2, right? Which is 1 over the square root of m to the 5th. Just making sure that negative exponents don't scare anybody. Okay, number 3, focus. Don't talk for a second because a lot of you are still talking. So notice, I have to say something. There are parentheses here. This is important because isn't both 10 and x raised to the 5th power? Because there's parentheses, yes. Isn't both 10 and x under a square root? Yes, because there's parentheses. So parentheses mean a huge thing here. So we have a square root. Now I have to use parentheses because both 10 and x are both raised to the 5th power. Guess what I see people do on a test or in the future? They'll go like this. They'll go square root of 10x to the 5th power. This would be wrong because this would be 10 times x to the 5th, meaning that only x is raised to the 5th power, which up here, both were raised to the 5th. This would be wrong for this problem, yes. Basically, yeah, but we know that it just means that both of those are raised to the 5th, right? My properties of exponents, technically that's that to the 5th, that to the 5th, right? Good question. Okay, so look at this one. We know this is 1 over the square root of both 10 and x to the 5th power, right? Okay, cool. Yeah. No, right now, good question. I see what you're saying. Should I simplify this? Right now, we're just switching back and forth, and in the future, yes, we will simplify. Hey, look at number 4. Ready, go. Write it. You go. Write it in radical form. On your own. Done? Hey, you said the what root? Okay, then what happened? Parentheses? 2x to the 7th. Good point. Okay, now watch. I'm going to change up this problem because watch, this is very interesting. If I change this to 2x to the 7th raised to the 1/5 power. Question for you. If I was looking at this problem, is 2 and x to the 7th power or just x to the 7th power? Just x to the 7th power, but aren't they both under a 5th root? So I would say 5th root of 2x to the 7th power, correct? And then that 1 doesn't change my exponents here, does it? Everybody see the difference in the two problems? This one had parentheses saying both were raised to the 7th power, where in this one only x was raised to the 7th power, but they are both under a 5th root. Okay. Okay, do number 7. So it says, rewrite this radical as a rational exponent. So switch it back to a rational exponent. So question, is both 7 and n under the cube root? Yes. Is both 7 and n to the 2nd power? Yeah, there's parentheses saying there is. So we would need parentheses. 7n, both were under a cube root. Roots go on bottom. Power goes on top. Okay, I'm going to ask you a question. If I change this to the cube root of 7n like this. Let me take those parentheses off and do this. Cube root of 7n squared. So my question is, are they both under a cube root? Are they? Yes? Right? So they're both under a cube root, correct? Now, are they both to the 2nd power? No. So 7n squared would be like this. So that the 2's not out here, putting the 7 to the 2. What exponent would go on top then to not change these? Yes, you guys are so smart. Okay, cool. Ready, go. Number 8. You guys do number 8. What's number 8? Good. B to the 1/2, right? Okay. Number 9. Do number 9. Are these two things different on number 9? They're different? Yeah, so are they different? No, we talked about they're the same thing, right? They're completely the same. Are they both under a square root? So we have an x under a square root, an x under a square root. What's the power here? 5. What's the power here? 5. Same thing, just putting the parentheses in different spots. We talked about that a second ago, how they're the same thing, just how the book wants to write it. Questions? Okay, do number 10. So I'm going to ask you a question. Since it's on, what do you notice about it? You just tell me what you notice. It's on the bottom, so what do we know about the exponent? It's negative. You guys are so smart. So are they both under a cube root? Are they both raised to the 2nd power? Yep, there's parentheses. So we would say 4n are both under the cube root, and they're both, so I need to put the 2 out here, to the 2nd power, and you guys said the exponent must be negative. That is a rational exponent instead of as a radical. Very good. You guys are doing awesome. Do 1 through 12, ready, go. Number 12 is the trickier one. Think about that. Where should your parentheses be? Okay, so number 12, you should have said, okay, since we have 1 over the 5th root of 3n squared, you'd say, okay, they're not both squared, so 3n squared, and then they are both under a 5th root, so 1 on top and then negative, because it's flipped over a fraction. Most of you got that, so I went through it really quick. Does that make sense? Moving on. Okay, everybody pay attention. So now we're going to be simplifying even roots and odd roots. Couple things to note. Even roots would be like square root, 4th root, 6th root, 8th root. Odd roots are like cube root, 5th root, 7th root, and so on. So everybody, by definition, just look. What squared equals 4? What else? Negative 2 squared also equals 4. Am I right? Okay, well, by definition then, the square root of 4 is technically what? Plus or minus 2, technically. Now, the primary root would be positive 2, but if I said to you find all the real roots, you would need to put plus and minus. Okay, what squared equals 16? What else? Yeah, negative 4 also equals 16. So by definition, the square root of 16 must be plus and minus 4. Does everybody see how this is working? What to the fourth power equals 16? What else? Negative 2 to the fourth power is also positive 16. So by definition, the fourth root of 16 is technically plus or minus 2. Does everybody see how this works? So when dealing with even roots, if I say to you find all the roots, you will have plus and minus answers. But with odd roots, this is not true. Here's why. What cubed equals 8? 2. Does negative 2 cubed equal 8? No. So by definition, if 2 cubed equals 8, then the cube root of 8 is only 2. Well, what cubed equals negative 8? Then by definition, the cube root of negative 8 is equal to negative 2 and only negative 2. So what I want you to notice is odd roots will either have positive answers or negative answers, depending if it's positive underneath or negative underneath. Does everybody agree? Okay, all good. So look at number 60, flip to the back. Number 60, flip to the back. Most people finish in class. If you complain, I'm going to put you in college prep. Here we go. Find all, you got to read the directions. Find all the real, we do not want imaginary, because we know that with square roots, we can have imaginary, right? Even roots. So we only want real, not imaginary. We're not dealing with quadratics where I'm saying find any solution. I'm saying find the real square roots, and I want all of them. So because of the word all, if there needs to be a plus or minus, I need to. So here we go. Take your calculator. Square root of 400 is technically plus or minus 20. The square root of negative 196. That would be positive and negative 14i. We're not dealing with imaginary. It says real, so there are none. There are no real roots here. Yeah, we can, but it would be I, and we're not dealing with I. Okay, here we go. Square root of 10,000. Plus or minus 100. Square root of 0.0625. Yeah, you're on the right track. 0.25. So we need a plus or minus because it'll work all. Okay, let's go on to 61. Find all the real cube roots. Now remember, will cube roots ever be I? No, because can't we have positive and negatives under odd roots? We just talked about why. Okay, cube root of 216. If you don't know how to do it in your calculator, hit math. Then go down to cube root. Cube root of 216. Positive 6. Cube root of negative 343. Negative 7. You're right. And only negative 7. You understand? You understand? You understand? How about you guys? Sweet. Okay, let's do this one. The cube root of negative 0.064. Type it into your calculator. And it's only negative 0.4. Very good. Okay, let's do this one. The cube root of 1,000 over 27. Don't type this one in. What you should do is, if you're dealing with fractions, do it in sections. The cube root of 1,000 is 10. Cube root of 27. 3, and only 10 over 3. Odd roots can have negatives. It's all good. Okay, let's go to the fourth root. So it says find all the real, only real fourth roots. Fourth root of negative 81. None, because that would be I. Even roots cannot have negatives underneath or else they're imaginary. Okay, now, do you know how to type this into your calculator? Let's teach you. Hit 4, hit math, go down to the x root. You just told your calculator you wanted it fourth root. So the fourth root of 256, yep, and we need plus or minus. Because technically 4 to the fourth and negative 4 to the fourth is 256. Hit 4, then math, then down to the x root. Fourth root, go for it. On your calculator. So in these directions, don't let them trick you. So it says find each of these real roots. Now, because it doesn't say find all of the real roots, we only go with the primary root. So that would be the positive root. So here we go. What's the square root of 144? 12. Now look, is this negative underneath the square root?
No.
No, so all is good here. That's negative 1 times root 25. What's root 25? 5 times negative 1. Negative 5. All is good. Can we take the square root of a negative? No, because it said real, so we can't. None. Let's go to this one. Cube root of that. Type it into your calculator. 0.1. Only positive 0.1. Fourth root of 0.081. 0.3, I believe. Well, because of the instructions, we're only going with the primary root. Cube root of 27 is 3. Well, what's the cube root of negative 27? No. Negative 3. Odd roots can completely and 100% have negatives. Because by definition, negative 3 to the third is negative 27. Don't get those backwards, okay? Okay. And then the square root of 0.09 would be 0.3. Any questions on that? Okay, let's get to simplifying bigger ones. Here we go. Focus, focus, focus. So guys, when simplifying radicals, we have nth root of something. You break it down into its prime factors. So you take the something, break it down into its prime factors. Now prime means nothing more multiplies to be it besides 1 in itself. Or you've broken it down completely where you can't break it down anymore. And then pull out groups of size n. So what I mean by that is if it's the square root, we'll pull out groups of size 2. If it's a cube root, it's got to come out in groups of 3. If it's a fourth root, it's got to come out in groups of 4. Does everybody understand? So look at 23. Here we go. The square root of 128, k to the third. So we need to break down 128. Give me 2 things that multiply to be 128. Any 2 words. 64 times what?
2.
Okay. Then 64 breaks down into 8 times 8. Now we could continue breaking 8 down, but if we're able to think on an advanced level, isn't it true that we're pulling out groups of 2? So it would not be necessary to continue to break down 8 since we can right here, right now, pull it out. Now think about it. We have k to the third, so that's 1, 2, 3. We're pulling out groups of 2. So can't I pull out a k? Now everybody listen so it makes sense to you, because I always have people say, I pulled out a 64. Well, why do we only pull out 1 8 for those 2 8s? Because we're technically doing the square root of 64, which is 8. Does everybody see? We're just square rooting it in sections, technically. So we pull out an 8. We pull out a k for those 2 k's, correct? Then left underneath, the square root was a 2 and k times, just a k, correct? 2k. Now, guys, there was never addition signs to begin with, so you never add anything. You pull multiple things out, you multiply them. Anything left underneath, you multiply them. Okay, let's do 24. Square root of 16x. What's the square root of 16? And then can x leave? There's not 2 of them, so 4 root x. Does everybody see how this is pretty easy stuff? Okay, let's get 25. Now notice this is groups of 4. They cannot leave the house unless there's 4 of them. 96 breaks down into 2 and 48, you said? Sure, we could use those. And then that breaks down into 8 times 6, am I right? 8 breaks down into 4 times 2. 4 breaks down into 2 times 2. 6 breaks down into 2 times 3. Now, guys, look how much potential there is for double dipping, I call it. Meaning, people will say, oh, there's a 4, a 2, 2, a 6, an 8, a 2, 2. You see what I'm saying? Yeah. Cross them out because they're really not there if you've rewritten them as something else. Don't double dip. Now, we're pulling out groups of 4. If there's 4 of them, they can leave the house. 1, 2, 3, 4. So those can leave the house. Now, look, this 2's got to stay. This 3 has got to stay. Now, I'm only going to do this first time. End of the 6. This is what we do in secondary 2. 4, 5, 6 M's, correct? Pulling out groups of 4. So 1, 2, 3, 4. And there we go. So everything I circled, I pulled out. So I pull out a 2, correct? Pull out an M. And then left under my, now guess what people do? They write square root, but you got to tuck in that 4. It was a 4th root. 2 times 3 is 6. And then how many M's were left? Yep, so M squared. Now think more densely, okay? Because you're never going to see me again, ever again, write it out like this. Because we should be able to think more densely at this point about this. So this, there's really no way around it. You've got to break it down. But over here, we should be able to think more densely. Now look, think everybody. How many groups of 4 are there in 6? 1. So we pulled out M to the 1. Does everybody see? Now think about it. Technically, we pulled out 4 M's out of M to the 6, technically. How many, if you pulled out 4, would be left over to get back to 6? 2. So there was M squared left. Does everybody see? Okay, let's do this one. 5th root of negative 96. Let's do, we've already broken it down, technically, haven't we? So we had our 2 times 48. You guys do it on your paper. Copying mine is no different than copying your own paper. Okay. Crossing out so I don't double dip. Okay, and then we've got to watch out for that negative. So it's okay though, because it's an odd, so our answer is going to be negative. Now we're pulling out groups of, I'm not going to write these out. Do not write these out. Think more densely. So we're pulling out groups of 5. 1, 2, 3, 4, 5. So I'm pulling out a 2. This 3's got to stay, right? Okay, so I'm going to go off to the side and say, okay, now also I'm pulling out a negative. Negative 2, I'm going to leave myself some space in case anything else pulls out. And then I'm going to go off to the side and write 5th root. Didn't we just say 3 was left? And we pulled out the negative, because that would be considered simplified. Now for this next part here, let's think advancedly. There's only x squared. We need groups of 5. So shouldn't x squared just stay under my radical? Okay, now think advancedly with me. How many groups of 5 are in 8? 1, correct? So we're pulling out y to the 1. Now if you pulled out, technically we pulled out 5 y's to make that y to the 1. How many left over to get back to 8? 3, correct? So then left underneath was y cubed. Sweet, right? You guys are good to go. So ready? Do this. I think you're good to go. Do 25 through 34. Do that section. Check with the people around you. My video is going. Okay. So with 16 it says, with 13 it says simplified. So notice right now, this is written as a rational exponent. Well, we know that that's equivalent to a radical, so it's much easier to simplify a radical. So let's rewrite this in its equivalent form. Isn't this equal to the square root of both 16n squared raised to the first power? Yeah? So isn't that technically the square root of 16n squared? Because anything to the first power is just itself. And now it's much easier to simplify, isn't it? Square root of 16 is 4. Square root of n squared is n. 4n is our answer. So do you see how rewriting this in radical form makes it easier to simplify? Okay, let's do another one. Number 14. So you say to yourself, it says simplify. So first I'd say that is a radical. Let's rewrite it in radical form. So this is equivalent to the square root of both 81 x to the 4th raised to the 3rd. Now careful, because both 81 and x to the 4th are raised to the 3rd. So this is how you should rewrite it. Don't touch your calculator. The square root of 81, how many 81s?
3.
Yeah, 81 to the 3rd power is 3 81s. And then raise a power to a power and you, okay. And now look, if we leave it spread apart, it's much easier to simplify. Isn't 81 9 times 9? 9 times 9 and 9 times 9. Now 9 could keep going, but aren't we pulling out groups of 2? 9 times 9 times 9 is 729. Agreed? And now think about it, guys. Everybody think for a second. How many groups of 2 are there in 12? 6. How'd you get that? 12 divided by 2, which is 6 evenly. So everything simplified, it all pulled out evenly. So no radicals left. Make sense? Pretty cool, right? Okay, let's look at 18. Once again, let's rewrite this. This is the same thing as the cube root of both 64x to the 6 raised to the first power. So because it's to the first, it's the same thing as the cube root of 64x to the 6. Cube root of 64 is 4, I believe. X to the 6, how many groups of 3? 2, because 6 divided by 3 is 2, so everything pull out evenly, x squared. Can you guys finish up that section on your own? I think so. Okay, do 13 through 22 now. Ready, go. Skip to this section, do some of these. Okay, so here is a new rule when simplifying. This is brand new. You've never seen this before. I'll explain why the rule is necessary in just a second. Write this down. So everybody, when simplifying a radical, there are times when your answer may need absolute values. So this is when your answer needs absolute values. Now remember, absolute values just mean positive answer, right? That's what, by the definition of what absolute values mean, they mean positive answer. So if you have an even root and your answer comes out to have an odd exponent, such as right here, the square root was an even root. It's simplified to be x to the third, which is an odd exponent. You would need to add absolute values on your answer. That is the only time. I'll explain why in just a second. Did you write that down for yourself? That's the only time in that exact order. Even root, your answer simplifies to have an odd exponent, so you need absolute values. So right here, look, even root, so square root of x to the fourth, it's simplified to be x squared. Do you see how that's not even root and odd? It's even, isn't it? We would not need absolute values, only in that exact order. Now here's why for anybody who can't comprehend why. So try to understand it. Think about it. If we're simplifying the square root of 4, we get 2, correct? Now if we simplify the square root of negative 4, don't we get 2i? True? So is there any instance when simplifying a square root where I could get a negative answer? No, it's either positive or I, correct? So think about it. Your answer when dealing with an even root will never be negative. So here, look at this answer. The square root of x to the 6, I get x cubed. If I plug in negative 2, isn't negative 2 cubed negative 8? Would that ever happen if we simplified a square root? Would we ever get a negative answer? No, it's either positive or I. So we would need to put absolute values to say, well, it's a positive answer. It really would simplify to be positive 8. Now here's why. Look, if you put in negative 2 to the 6th power, everybody. Type it into your calculator for me. Negative 2 to the 6th power. No, it's positive. You didn't use parentheses in your calculator. Negative 2 to the 6th power. Square root of 64 is positive 8. Does everybody see that it really did not come out to be negative, even though I plugged in negative 2 right here? Look, if I plug in negative 2 cubed, don't I get negative 8? So do you see why I need absolute values, everybody? Okay, now think about it right here. Wouldn't this 2 take care of the negative for us? Something squared will be positive, so we wouldn't need absolute values because the exponent is taking care of the negative. Does that make sense? And then odd roots can have negatives in their answer. Okay? If you don't understand that, it doesn't matter. Memorize the rule and do it. Here we go. Go to 64. Let's do this. Flip over to the back. Simplify and add absolute values when necessary. Square root of 81x to the 4th is 9x squared. Let's check. Even root? Yes. Odd exponent? No. 9 is not negative, so we're good. We don't need to put absolute values here. Didn't fit the criteria. Even root, odd exponent, yes. Yeah, because the square root of 9 is not negative, right? So we're good. Numbers won't ever need it. Square root of 121 y to the 10th. It becomes 11y to the 5th. Now look, even root, yes. Odd exponent. Yes, so we need to add absolute values in our answer. Yes. Yes, it would be. Okay, let's go on. Very good question. Do not put absolute values around 11. 11 is already positive. Good to go. Cube root of 8 is 2g squared. Even roots? Nope. So you do not need absolute values. Okay, moving on. Cube root of 125 is 5. X to the 9th divided, what's 9 divided by 3, everybody? So it came out perfectly. X cubed, look, even roots? Nope. So you don't need absolute values. Even root, odd exponent, period, end of story. Okay, moving on. Looking at this one, since this is multiplication, we can look at this separately, in a sense. Square root of 25. 5. Now this is connected, but we can look at this. What's 4 divided by 2? 2. So don't we have our x plus 2 squared? Yes. So you don't need it, ever. No, because can't we have positive or negative? Yes. So only in that exact one case. Even root, odd exponent, period. Never changes. Okay, look at this one. Even root, odd exponent, nope. Good to go. Moving on. This is the square root, right? We don't need absolute values because it's an odd root. We didn't add absolute values. The cube root of 125 is 5. And then the cube root of x to the 9th is x cubed. So that's our answer. Okay. Look at this one. Everybody, you would cube root this in sections here. So don't let it throw you off. On top, we have the cube root of 64, which is 4. Now we have the cube root of x to the 9th on top. 9 divided by 3. X to the 3rd. Now on bottom, careful, this is on bottom. What's the cube root of 343? 7, everybody. Make sure if it started on bottom, it ends on bottom. Now look, even root? Nope, we do not need absolute values at all. Okay, are you guys good? To finish up the next section. Okay, what I want you, to finish up that section. Do 64 through 66, go. Without the absolute values. Okay, on that section, what you get is your answer. X over 3. Now check, even root? Yep, odd exponent. 1 is odd, so don't I need absolute values? You don't need it around the 3. 3 is 3. Let's do this one. What does this simplify to be? 6x what? Y to the 3rd. Now look. Odd exponents? Wait, even root? Yes? Odd exponent. You guys, is 1 an odd number? Okay, so say yes. Odd exponent here. So we need absolute values around both of them. Okay, let's do this one. What does this become? M minus n technically to the 1st, am I right? Even root? Odd exponent? So we would need absolute value. Okay, hopefully that makes sense to you. Okay, what we're going to do now is go on to multiplication. So everybody listen. So when multiplying, we're just going to be doing basic radicals, and then in a minute we'll learn addition and subtraction. So look, just look at my examples. 2x times 3x squared. Can we multiply these? Yes, because multiplication can be reordered. Isn't this 2 times 3, which is 6? When you multiply, you add your exponents, don't you? So this would be 6x cubed, am I right? Now, even though we could multiply them, could we add them? No, they're not like terms. You're right, they're not like terms, right? Okay, so look right here. We're multiplying the square root of 3 times the square root of 3. We can put these together since they're both under a square root. We can literally write them under a same square root. So square root of 9 is 3. Or can I just say pull out those 3's? Right? Okay, sweet. Now look, 1 square root of 3 plus 1 square root of 3 is how many square roots of 3? 2. Don't answer unless you're going to be serious. 2 root 3. Oh, I thought you weren't. I thought you were being smart. Okay, sorry, that was rude of me. I deserve owe you an apology. Okay, that was a good example of the wrong answer. Root 6 would not be it, but that's a common mistake. So root 3 plus root 3 is 2 root 3. Does everybody understand? Just like x plus x is 2x. Does everybody see? Okay, look right here. Negative 4 root 3 times root 8. Well, since they're both under a square root, we can literally think of this as negative 4 times the square root of 3 times 8. So now we can simplify our answer. We would want to break down 8 into 4 times 2. 4 breaks down into 2 times 2. And then we wouldn't double dip. Are we pulling out groups of 2? Now be careful because we already had a negative 4 on the outside. Negative 4 times 2. Negative 8. This was left and this was left, wasn't it? So root 6. Now because we have negative 4 root 3 plus root 8, because they're not like radicals, like in the example above, this was a root 3 and a root 3, we could put them together. They're not the same root, so we can't put them together. Does everybody get it? Okay, we'll get into more details in a second. Okay, here is the rule. When multiplying radicals, you can combine the radicals if two of the following is true. If they have the same radical, you can put them under the same radical. Does everybody see? Or think about it. If you have the same base, it's okay that you have different radicals. Well, why? Because that's 5 to the 1/2 power times 5 to the 1/3 power. Am I right? When you multiply the same base, when you multiply, you add your exponents. So do you see how even though the radicals were different, since the base was the same, we could put them together. So this would be 5 to the 1/2 plus 1/3. You would do it in your calculator, math, enter, enter, and you get 5, 6. So isn't my answer? You would do it in your calculator, you'd add them up, and it would do all the hard work for you. So then isn't that the 6th root of 5 to the 5th power, everybody? You see how to do it. Okay. Could we? We only have 5 5s? How many groups? How big of groups do we need? 6. So no, right? This would be our final answer. Does that make sense? Okay, look at number 35. We've already done these two, actually. Go to 37. Here we go. Can we multiply these together? Yeah. Yep, they're both under a root. That's the same, so we can put them together here. So now, wouldn't I just break it down? Why actually multiply it together when you're going to then just break it back down, right? So then 4 breaks down into 2 times 2. Don't double dip. So pulling out groups of 2. When I pull out a 5 and a 2, negative 2 times 5 times 2 is negative 20. So the radical went away in this example. Yes. Oh, hey. Yes. Yep. Okay, let's look at 43. Looking at this, isn't this just all multiplication? Then we can reorder it, can't we? Negative 2 times negative 4 times root. Can't I put these under the same root? Yeah, because they're both under square roots, so 4 times 20. Now, it would be unnecessary to actually do 4 times 20, but we could break 20 down into 4 times 5. 4 breaks down into 2 times 2, am I right? Oh, let's not do that, though. Only because we have 2 4s. Now, careful, isn't this 8? 8 times 4 is 32. What was left? Root 5. Very good. Are we going too fast? Or are you like, nah, I got it? Okay, sweet. Do this section. Ready, go. 35 through 44. Multiply radicals. Now we're going to talk about adding and subtracting. Now, adding and subtracting radicals are more picky. 2 things have to be the same to add. It's not like multiplication where it's less picky. Both things have to be true to add. The radical has to be the exact same no matter what. And what's underneath has to be exactly the same no matter what. Does everybody hear that? Or else they're not alike, so you can't put them together. So everybody look. If we have x plus 2x, don't we get 3x, everybody? So then look. 1 root x plus 2 root x is 3 root x's. The apple doesn't change. Does everybody see? 2 root 3s plus 5 root 3s is how many root 3s? 7 root 3s. Now look. 2x root 2s plus 5x root 2s is how many x root 2s? 7x root 2s. The apple doesn't change. Look right here. Square root of x plus square root of 3. Can't do it. We could multiply them, couldn't add them. So can't Now look, square root of 2 plus 2 root 3. Can't. They're not the same underneath. Not like terms. That's adding an x and an x squared, basically. You know what I mean? Okay, look. 2 root x plus 3x root x. You still can't combine them. This was an x root x. This is just a root x. Does everybody see how you could not combine them? They are truly not the same. Does everybody understand? Okay, let's do the problem on the homework. Go to 51. Now look, right here, right now, notice we have 2 root 45, so they're like. So we have 3 root 3 plus how many root 45s? 5 root 45s. Now you cannot stop there. You've got to check to see if your radicals simplify. Well, it looks like 45 does. 9 times 5, 3 times 3, pulling out groups of 2. So careful, we pulled out a 3 and 5 was already out there. So we have 15 root 5. So that was 15 root 5. And wasn't it positive? And then we have our 3 root 3. So can we combine them here, right here now? No. So there's our final answer. Okay, go to 52. Looking at it right here, right now, notice nothing is the same. We can't combine anything right now, correct? But we don't know really until we simplify. 4 times 5, 2 times 2. Are we going to pull out a 2? Don't double dip. Careful, because on the outside already was a, yep, good, was a 2, so 4 root 5. Guys, all I've done is simplify that piece. Now we have minus root 3. That part didn't simplify. Right here, we've got to break it down. 4 times 3, 2 times 2. Careful, wasn't there already a negative 2 on the outside? So negative 4 root 3. Now look at your final answer. What can we combine? The root 3's. So 4 root 5 minus 1 root 3 minus 4 root 3's. How many root 3's? Negative 5 root 3's. There's our final answer. If that makes sense. Pretty basic stuff, right? Today we were just doing the basics. Okay, can you guys finish this section by yourself? 51 through 59. Okay, so here's what you're going to do. You can do the entire worksheet except for this teeny tiny section because on a regular day we would have been able to get to it, but where it's a short day. Do not cross these out. We've got to learn them next time. 45 through 49. This section we've got to learn next time. Anything else you should be able to do. Now everybody listen. Do not skip the story problems on the back. Those are literally asking you to take cube roots and fourth roots. And that's how they'll ask it to you on the ACT. Is can you take a cube root, but they'll ask you in a roundabout way. Does that make sense, everybody? Think a little. Like, don't just say I can't do story problems because you don't get to say that anymore. This is advanced math. Plug in what you know. It's literally taking cube roots and fourth roots. So if you say I don't know how to do it, then I'm going to laugh in your face. Okay, ready, go.